Welcome to another episode of Geometry, and we continue to learn about circles. So here we have a circle, and we're going to be talking about tangents, okay? So a tangent is simply a line that intersects a circle one time, okay? This definition is already on your paper. So here we have two tangent lines intersecting the circle once. And so what happens when I draw a segment from the tangent to the center of the circle? Like this. So it appears that here we have a right angle, right? And it also looks like we also have this segment being perpendicular, those two segments being perpendicular. And that's always going to be the case, okay? A tangent and a radius, right? Because AC is a radius, a tangent and a radius always create perpendicular, okay? They always intersect perpendicularly. This means that we have a 90-degree angle there and we have a 90-degree angle there. So what would happen if you think I would connect this point and this point here? What kind of shape do I now have? If this is point, let's call it J for Jimenez, okay? What kind of shape is shape ACJ? What shape it is? Yes, it's a right triangle. Perfect. So when you're dealing with this, remember all the strategies that you have on right triangles. Okay, so now we actually have a point outside the circle. We haven't really dealt with points outside of a circle, but here we go. So if we have a point outside the circle and we have a tangent to the circle, like these two here, we say that those two are going to be congruent, okay? All tangents drawn from an exterior point to a given circle will have the same length. Now, let's show why CB has to be equal to BD. Well, as we can see here, we have two right triangles, and we're going to prove that they're congruent, okay? So first of all, we have AB is congruent to AB because of the reflexive property, right? And we also have that AD is congruent to AC because they're both radii of the circle. Well, now I have the hypotenuse of the circles being congruent and one of the legs. That means that these two triangles are congruent by HL. There is the proof, okay? So now that we have that these two triangles are congruent, well, lastly, we finally know that these two sides are going to be congruent, right, by CPCTC, right? Now you know that this is always going to be the case. Let's look at an example. All right, so here's a classic example. We have 3 points outside of the circle, and then we also have a bunch of tangent segments, right? We have a bunch of tangent segments. We have AD, AE, CE, FC, and FB, okay? All of these segments are tangent. What does it mean? Well, let's put in some numbers here, okay? They gave us that these segments are AD is 5, right? And so once we label them, I know that CF has to be the same as the other tangent touching C. Okay, so the other tangent is going to be CE, and that is also 9. Okay, so let's finish labeling this triangle, and this is going to be your CFU. Okay, so finish labeling the triangle and determine the perimeter of triangle ABC. Okay, so perimeter, remember, it just means to add up all the sides of a triangle.